Small wonder you were having trouble. The machine, sir, is foreign.
Hello again. Welcome to this, hopefully, yes, it really is going to be the last segment about this L12 version 5. Can I say, before we start, if you're going to buy one of these modules or already have one, it's vastly important that you watch all, I think, 4 videos on this subject, because if you don't do all these modifications, you will not get good performance from these boards. Later in this video, I'm going to have a live Skype call with Ron, so you'll be able to put a face to the voice that you've heard on the previous video and the various comments. And I have to say that this project is largely Ron's doing. I'm just the bearer of the well, I was going to say the good news, but well, there is good news, but the original news, of course, was bad news about this board. Anyway, he's going to talk to you a bit about the circuit changes that we've made and why. Now, before we go any further, there is another slight issue that we've found, that on certain circumstances, i.e. if you're running it near clip, and I have to say that's a lot of power, but under certain circumstances and with the lowest gain, it is possible, as you'll see in this slide, that there is still slight instability. And it's really only come to life after we've done murderous tests, i.e. throwing it into distortion, square waves, getting the heatsink too hot to touch. So they're all things that hopefully you won't do, but nevertheless, it's not as it should be. You should be able to do all these things to a good amplifier and not have problems. As you could see on that slide, there is still slight instability, but it is interclip. But we found a way to get around it, and this is it. It revolves largely around resistor 4 and resistor 3 and Q2 and Q4. And there's a very simple way to deal with this. Now, it sounds very simple, but it did take several days of messing about to finally resolve this. And this is all you do. You basically remove Q2 and Q4 from the circuit, and it involves nothing more simple than a shorting link across resistor 3 and 4 as shown in this slide. It's as simple as that. Ironically, the circuit is becoming more and more like the original L12 Mark 4.2, which was the last reincarnation. The main reason for doing all these mods out of the box, as we've discussed and we've shown before, it's basically e-waste, and our advice is still basically
don't buy it.
Don't buy it. Why would you buy it unless you like modifying boards? And even then, we don't know if it's better than the previous model, do we? We haven't really been able to listen too much yet.
Working on it, but as of yet, we don't really know.
Let's have a chat about the modifications and why we're doing this video now, because we thought we'd finished it all before, but for another quite simple modification, it's quite a bit better and, dare I say, as stable as it's likely to ever be. Describe the latest mod, Ron. Why basically?
The latest ones?
Of the 2 input transistors, or the...
Yes. The problem was that after doing everything else, the other modifications, the minimum modifications that have been discussed before are essential. That's all there is to it. Still, there is a little bit of instability just as it enters clipping, especially on the bottom end, believe it or not, is the trigger, not the top end. So on the bottom end of the waveform, you can watch it as you increase the signal. It becomes unstable at the top end. That's the clue right there, that there's something else going on. And another clue is that, as you yourself found out, when you reduce the gain too much, it gets worse.
Yes.
So, all right. So when you think about that, what is happening when you reduce the gain too much? You're driving the inputs harder with your preamp or signal source. Okay. So thinking about that, I looked at the differences between that and the original L12. The original L12, of course, just had a pair of transistors for the inverting and non-inverting. Okay. The problem was that LJM claims that he was trying to increase the input impedance, which he did. But the problem is that it became too sensitive. It became too much. So I thought about, well, how can I just reduce that or eliminate that and go back to the original design? Turns out it's very easy. There are those two 2.2K resistors. If you simply short across them, you are shorting from the emitter to the base of the new transistors, and they disappear from the circuit. So now all you have is the original two transistors, and it worked.
Much the same as the original circuit, ironically.
Exactly. You're reverting back to the original circuit, and lo and behold, it works.
Does doing that actually reduce the gain or not?
I don't think it makes, it makes no difference at all in the overall gain of the board, none whatsoever. It makes no change at all. What it does do is it reduces the input impedance. If you're going to be driving this with a preamp of any sort, of any good caliber, you don't care.
No.
What's the difference?
It's output, isn't it?
It doesn't matter. So if you take those two resistors, short across them, or if you're building it from a kit, just simply put in two jumpers and don't put the extra two transistors in. Why waste them? That was the final key or piece of the puzzle, if you will. And now it's actually pretty respectable.
One of the other mods that we did earlier was to virtually short out or eliminate the series transistor in the rails.
Yes.
Because initially that was one of the major causes of instability. One or two people have written in the comments saying we've effectively removed all the smoothing. But that's not really true, is it?
It's not really true, no. You have the 100 microfarad capacitors past them on the input side of them. And so you have not removed it. True, it's not the same as it was on the original L12s, where you had the 68 ohm resistors, and I think there were 100 microfarad capacitors past that, but it's not quite as good. But the problem of it was that now you have instead of having just a resistor, and by the way, there's a story behind that, you have just a pair of resistors there and a couple of capacitors. All of a sudden you have a nonlinear element. You have a capacitor multiplier, which in theory works pretty good. Think about it a second. How much current is being drawn by those input stages? It's
a few milliamps.
A handful of milliamps. And he's put these monstrously large transistors in there. They're overkill. And so what happens is you just introduced instability by introducing nonlinear elements into the supply rails. And so they're not regulators. People seem to think they're regulators. They're not. They're capacitance multipliers. And if you simply short across them, it gets better. It gets immediately noticeably better. The story I was going to relate behind that is I started out again looking at the original L12 diagrams. And I said, wait a minute, he just had two resistors, 68 ohms. So I thought, all right, I will simply put 68 ohm resistors across those devices. It helped. Wasn't fixed, but it helped. So I thought, all right, that's good. I'm on a roll here. So I went down to 47, 22, and 15 ohms. And at 15 ohms, it was just almost fixed. I thought, well, this is silly. So I just jumpered across them. Great.
Because
It
15
works.
ohms is neither here nor there. You might as well link it, really.
Just link across them. That brings up the subject, which I think somebody else commented about. Well, why not just remove those two transistors and the two input capacitors and the input side capacitors and the two resistors? Yeah, if you do that, the board becomes an oscillator. I mean, a really good one, actually, at about 2 megahertz. The problem is the board layout. There is something about the board layout.
That's really the whole problem in a
Yeah,
nutshell, isn't it?
it
The
is
board layout is just a
terrible.
certain four-letter word that starts with C.
It really is. So what happens though is if you simply remove those parts, and believe me, you and I both tried.
Yeah.
If you remove those parts, or don't populate them to begin with, in my case, because I had the kits, the board just goes into oscillation. It becomes you have 1 or 2 megahertz fuzz
Yeah.
continuously. No matter what you do, you can
And obviously you can't hear that. It might
no.
interfere with the bats in the neighborhood or the dog, but the effect it has is to make the sound appear harsh
Well,
because of the oscillation, I guess.
and the quiescent current goes way
Yes,
up.
it does.
Way up. I mean, I'm talking
Yeah.
about hundreds of milliamps, and all the devices get very, very hot.
Yeah.
It's just, there's just no excuse for it. There's no way to live with it.
While we're talking about quiescent current, maybe you'd like to comment about why, because that heat sink at the back there with the two transistors back to back gets really hot, doesn't it?
Very hot.
And you've actually reduced the current now by what?
2/3. Once again, I reverted it back to what the original L12 was. I did that actually without looking at the L12 circuit, believe it or not. I settled on the 100 ohms as an ideal value, 100 to 110 ohms, somewhere in there. And then I referred back to the original L12 and I said, oh, that's what he used there. Well, gee, I guess it worked, didn't it? What that does is it puts less strain on the QI control transistor. It puts less strain on the top current source, less strain on the voltage amplification, the VAS stage transistor at the bottom, the 5551. It just puts less strain on everything. Okay.
And before anybody comments, that doesn't mean there's loads of crossover, because the current in the bias circuit is still much the same.
You have to adjust it. You have to adjust it back to the same.
Yeah.
But yes, it ends up being the same.
And
Fortunately, you have an adjustment.
we've kind of settled on about 40 or 4.4 millivolts, which is 40 milliamps,
Right.
which seems to be quite well. But you do need to set that carefully. I've gone over how you set the quiescent current in the previous video.
Yeah,
But
let it
it's
warm up.
quite important, because you can either end up with quite a lot of current or no current at all. So you do need to refer to that video and set it up the way I've suggested, and then it's as stable as it can be. It rises with heat, obviously, but it soon throttles back to a fairly consistent 40 odd milliamps. So
It settles right back down.
if you haven't seen the other videos, you really must do, because, and the worst thing is that you listen to a piece of this video and you haven't heard the other ones, and the next thing you know, you're writing to us. And we love to hear from you, but it's very frustrating for both of us if we have to write down what we've already covered in previous video. And as to the guy that said that we should change various transistors and do this, of course we should, but that's a different amplifier. This is the one you got, and you paid your dollars for it.
Yep.
And all we're trying to do, or we've succeeded in doing, is to make it work and be a reasonable product. We're still not sure whether it's better or worse than the original L12. The latest version was 4.2, wasn't it?
4.2, and actually, I have 4.2s here, which I just received, which is a whole other story.
Well, to cut that quite long story short, if you have a choice and are looking to buy an L12, the 4.2 is the one you should try and get.
Absolutely, yes.
And
but you have to modify it too. You have to add a QI pot.
yeah, that's true.
Worth mentioning, I'm sure Mike is going to show you a chart of about 15 things that have been tried. These were not just, we didn't just throw things at a wall and see if it stuck, so as the saying goes. These were done methodically. And if you look at the chart, you'll find that virtually all of the things were either suggested, somebody else has suggested them, whether we did it first or not. Somebody else in the comments has said, oh, what, did you try that? Yes, we did. This is all you need to do to fix it. No, it isn't. Unfortunately.
They're all things that work probably on a well-designed amplifier.
Yes, that's a good
problem.
point. But there are a couple of things that actually make it much worse. And they're noted in this chart. In the end, it takes all of the modifications. Again, sorry to sound like a broken record, but it takes all the modifications, the minimum modifications and the final modifications to get it to the point where it's even usable. And so once again, please, we'd love to hear your thoughts, but please look at this list. If it's already on this list, we've already tried it.
The whole mods are going to take you 15 minutes. Can't see it's going to take any longer than that. It seems to be taken us a long time, because invariably you've got to take the board off the heatsink. And the board's been off and on these heat sinks so many times now that I've actually had to use new screws because I've burned their heads over.
I had to retap the holes in my heat sinks too, just for the same reason.
And when you look at some of the photographs that I have or will show you, it does look a little bit like the boards have been dragged through the walls, and they have. But there's no reason for your boards to look like this. I would suggest that most of the mods where we put them on the back, where you basically leave the component in the board, that you do the mod on the back. And then if ever you want to, for what, can't think why you want to, but you can always reinstate it as was. You mentioned the quiescent current. I've mentioned this on previous videos, but it's so important. I think we should mention it again. Whether you assemble this yourself or you bought the ready-made one, if you bought the ready-made one, get rid of that gunk that's stopping you adjusting it and turn the pot fully anti-clockwise, which will give you minimum current, because if it's the other way round, you could be drawing, well, I don't even want to think about what the current.
A lot of amps.
One or two people have said about the different voltages available. It does say in the propaganda, use maximum of 55 volts.
Right.
I would suggest that, I mean, that is really maximum, and it's going to develop a lot of heat, and it will produce a lot of power. This is a powerful amplifier.
Absolutely.
And they're proper watts. They're not Chinese watts. So if I tell you it's produced, in fact, with 50 volts across it, I measured 128 watts prior to clipping, and that's into 8 ohms. I haven't even tested it into 4 ohms, but I know that you're running it at a lower voltage.
Well, and a lower resistance. As it turns out, my dummy load, which is strikingly similar to yours looking.
Yeah, it does look a bit like it.
Mine is 6 ohms. So my 6 ohm load, I've been running into 6 ohms, and it gives a good comparison. But my bench supply is only good to plus or minus 31. It maxes out at 31.
Yeah.
So at 31, I can get 66 watts into 6 ohms. That's short of clipping, of course. In my AV amplifier build that I'm actually putting these things into, I'm running closer to 40 volts, plus or minus 40 volts. I expect to be able to get it 75 to 80 watts without any problem at all.
So your speakers are 8 ohms, aren't they?
Speakers are 8 ohms, that's correct.
Yeah. So what transformer voltage have you got to get that?
27, not 27.
Probably what, 150 watt rating, is it?
I would say probably, yes. And I'm using a rectifier and filter board that's identical to yours, except that it only has 50-volt capacitors, which is,
Yeah.
oddly enough, I have a tap on that transformer where I actually could run it up to 50 volts, but it's too close. It's too risky with the capacitors I've got.
I've been using mine on the test bench here at 50 volts on stabilized supplies, mainly to just check that it can be done. But certainly don't use 55 volts. I mean,
No.
that's it. The heat sinks alone would have to be enormous because these are genuine watts. That's what makes the difference.
The watts we're talking about, by the way, just to be clear, are RMS watts. They are not.
Just
they
right
are
clear.
RMS.
That's clean sound before the distortion goes.
That is correct. Yep.
Oh, do we want to mention distortion at this stage? We haven't really talked about that.
Well, you have a chart for that.
Yeah,
I think it would be worth showing the chart, but stress that it's simulation.
And with the modifications, it brings it down even more.
That is correct.
Well, I think that's it. We just have to wish all our viewers good luck and hope the smoke doesn't rise too much. But we've had, of these 4 modules that we've been doing, even though we've done some quite horrific things to this, we've not managed to raise or made any smoke at all, have we?
I haven't burnt mine up yet.
Right, Ron, thank you for your time. Appreciate it. And I'm sure you'll get loads of letters, which is good because I usually get.
Okay.
I spend about 4 hours a week answering letters, and I'm sure it's only fair you should get your share.
Well, somebody commented in the last video, the mythical Ron. Yeah, well, I guess I am. Hi, I'm mythical Ron.
Thanks, Ron. I'll say goodbye.
Bye. Take care.